Hi there again. This lesson I want to do some actual problems with the exponential function ex, so that you can see how we use the differentiation that we learned from previous lessons to solve particular problems in that function. For example, finding gradients or tangents or normals and so on. So let's have a look at the first question that we deal with. So we're going to do a few of these. So let's start off with something a bit straightforward and easy. So this is question 1. So find the exact gradient of the tangent to the curve y is equal to ex at the point 1e. So what we need to do is just find the gradient, right? So we just need to find the gradients. And the steps to finding a gradient are that 1, you need to do the differentiation. And 2, you need to substitute x, right? In this case, you need to substitute x is equal to 1 into to find the gradient. So let's do the differentiation. So how do we differentiate this? Then we know the differentiation of ex is equal to ex. And we're going to sub 1 in now. So this will mean that this will be, the gradient will be m is equal to e to the power of 1, which is just e. Now they want the exact gradient. So you have to be careful with questions. Make sure you read the question carefully, because you should not write 2.718 or 2.72. Sorry, you shouldn't be writing those. We know that e is roughly around 2.718, but we should not write this because they want the exact answer. So you would write this. This is it. So do not write 2.78. This is your gradient. Same here. So find the exact gradient of the normal this time. So normal is at 90 degrees to the tangent. So we need to find the gradient of the tangent first, and then we can find the gradient of the normal. Now remember, here they've got the functions y is equal to e2x and x is equal to 5. So let's do the derivative first, dy dx. So if y derive e to the power of 2x, this would become 2 times e to the power of 2x, right? So if I substitute x is equal to 5, right, this would be 2 times e 2 times 5. So this would become 2e to the power of 10. So this here is my gradient. But this gradient is for the tangent. What I want is the gradient for the normal. So of course, for the normal, it's a negative reciprocal. So the gradient for the normal would be equal to negative 1 over 2e10. And that's your answer there. Moving on to the next question. So if we say that this is question 1 and this is 2, let's go to question 3. Find the equation of the tangent to the curve y is equal to minus ex at the point 1 and minus e. So we're finding the equation this time. Read the question carefully. This is not after gradient now. It wants the equation of the tangent. So we're going to need to use the equation of a line, y minus y1 mx minus x1, right? Now we do have the point. The point is 1 minus e. It's a minus in front of the e. Now the curve is y is equal to minus ex. So the first thing we should do is derive it to find the gradient. If we derive that, that's minus ex. If I substitute 1 in, because x is equal to 1, to find my m, so m would be equal to minus e to the power of 1, which is just equal to minus e. So this is my gradient. I substitute my gradient into my formula for an equation of a line using this point that they gave us, right? So y minus, now that's minus e for y, as you can see, and this is equal to m. M would be minus e, and this is x minus, now the x point is 1, so this is minus 1. So this will be y plus e is equal to minus x plus e. Now these two cancel out, so it would just be y is equal to minus ex. So that is your equation of the tangent.